Okay, so now we're going to talk about solving radical equations. So if you have something like the square root of x equals a, you could think of that as x to the 1/2, right, equals a, and then you could raise both sides to the second power. Usually we don't bother changing it to the exponential notation, but you could do it that way. So the rule kind of is, whatever your index is, you're going to raise to that power. So if it's a square root, you're going to square both sides. If it's cubed root, you're going to cube both sides. So let's say you have the nth root of x equals a. Then you're going to raise both sides to the nth power. Okay? And that's the rule. Okay. The only thing is, we have to check these. Check answers. Okay. And this might be kind of a long video because I have 2 examples. All right. So this first one, we have the square root of 15 minus 2x equals x. So we're going to raise both sides to the second power. And then that's going to give us this equation. 15 minus 2x equals x squared. Now that's quadratic. I'm going to put everything on the right. So 0 equals x squared plus 2x minus 15. I'm going to solve with factoring. It is a quadratic equation. I could use the formula. I could complete the square, but I think I can factor this okay. I just can't factor and talk at the same time. Okay, so I get 5x minus 3x, that's 2x, and negative 15, it all looks good. Okay, so I get 2 solutions. X could be negative 5, or x could be 3. Now, maybe both of those answers work. Maybe neither one of them works. Maybe one works and one doesn't. We don't know, and we have to check them because we squared both sides. It really has to do if you're raising it to an even power. Okay, so when you check them, so here comes the check, you have to go to the original equation. That was the original equation. So first I'm going to try the negative 5. So I'll have the square root of 15 minus 2 times negative 5. Does that equal negative 5? So I'm putting in negative 5 for both of the x's, right? Okay, so on the left I get 15 plus 10 square root. This isn't going to work, but just so you can see it. Okay, the square root of 25 is 5, not negative 5. So no, that one doesn't work. Cross it out. Okay, maybe the 3 works. So we'll try that. I'm going to run into my other problem. Okay, the equation was 15 minus 2 times 3 now. I'm putting in a 3. Does that equal 3? So I get the square root of 15 minus 6, which is the square root of 9. And yes, so the 3 worked this time, but the negative 5 didn't. But that's why you have to check them. Okay, so I checked them and the 3 worked. There's no guarantee that one's going to work and one isn't. There's no guarantee that both of them will work or that neither one will work. You just have to try it. Okay, so now let's try another example here. Again, this is a bonus one, but I thought it would be useful for you to see this one. So I see the radical. That means I want to square both sides. It was a square root. Okay, so on the left, I get x plus 3. Because the square root and the square, they're undoing each other. But on the right, I have to multiply this out. So it's a binomial times a binomial. And when I do that, I'm going to get 9x squared minus, well, it's going to be minus 3x if you use FOIL, plus 1. Now, I'm going to simplify that. I have lots of room on my screen here. You're probably like, but we don't have lots of room on our paper. Okay, and I'm just going to subtract the 3. What am I doing? I'm trying to set it to 0 because this is quadratic. Okay. Do I think this is going to factor? I think it is. I need two numbers that multiply to be negative 18 and add to be negative 7, and I think negative 9 and 2 will work. Okay, so let's just go through the factoring process here. And I get, try to be consistent here. So it looks like I'm getting x minus 1 as a factor and 9x plus 2 as a factor. Now you can write those out and solve each of those equations, but you're going to get x equals 1 or negative 2 over 9. Those are my solutions. Now I have to check those. Okay, so I have to go way back to the original, find that original equation. So here comes the check. Sometimes the check's not as bad as you might think. Sometimes it is. So I'm checking the original equation. My one answer was 1, right? Okay, so let's try the 1. 1 plus 3. So I get the square root of 4, and I get 3 minus 1, so 2 equals 2. Yeah, that one works. Okay, so yay for the 1. 1 works. Okay. Now I have to check it was negative 2/9, right? Okay. Negative 2/9, a nice fraction there. Well, let's see if it works. I'm probably going to need a little more room for the fraction work. So the square root of negative 2/9 plus, let's see, that's 3 over 1, so it's going to be 27 over 9, right? Multiply by 9, multiply by 9. Okay, yeah. And then on the other side, I'm getting negative 6 over 9 minus, I'm going to make that 1 9 over 9. Okay, so on the right, I'm going to do the right first here. I get negative 15 over 9, and I don't think I have a good feeling about that. Unless I wrote something down wrong. Let me go back up here. No, I didn't write it down wrong. Okay. And then on the right, I'm getting 25 over 9. So on the right, I get 5/3 if I take the square root of that. On the left, if I simplify it, I get negative 5/3. So that one doesn't work. But it's not because it was a fraction. It just didn't work. So, okay. Sometimes they both work.